The next topic that I want to talk about is relative velocity. When we refer to position, we were referring to the location of an object relative to a point of reference. I mean, with respect to a point of reference, or relative to that point of reference. When we talked about it, we said, alright, the position of an object depends on the location of that object with respect to that point. Okay, so at that point we could say that this is 5 in the x and 3 in the y. Okay, we use that for position. Now velocity is something similar. We refer to velocity, we should also be talking about with respect to other objects. It is possible to think of yourself as being stationary inside of a moving vehicle. Let me put it this way. If you were driving along on a perfectly smooth road, no bumps in the road, at a velocity of 30 meters per second, okay, and a car drives by you at a velocity of 35 meters per second, okay, the car that drives by you would appear only to be moving a total of 5 meters per second. It's not pulling away from you very fast. I mean, talking about 30 meters per second, that's a healthy speed. And the difference of being 5 meters per second, it's still pulling away. It's still going away from you, but it's not pulling away from you at 35 meters per second. It's pulling away from you at 5 meters per second. So we'd say that the relative velocity of the second object is 5 meters per second, and not 30, or not 35. I'm sorry. So if this is you, okay, if this is you traveling at 30 meters per second, excuse me, and a car passes you at 35 meters per second, you can say the relative velocity of this car is 5 meters per second. It's only moving 5 meters further away from you for every second. Okay, which is pretty fast, but not nearly as fast as 35 meters per second. So that's kind of the basic understanding of relative velocity. You can also think of it this way. If we talked about that exact same car, but now it's heading at you, so it's a 2-lane road, here's the separation in the road, and now it's heading at you at 35 meters per second. It would appear as if that car that's heading at you is traveling with a total velocity, I'm sure I'm off the board by now, not quite that far, of 65 meters per second. It appears that it's moving relatively fast, which makes sense. If you were just to watch that car come at you and you think you were stationary, it would appear to be going really quick, because you're covering a distance and this car's covering a distance, and they're collapsing that distance every second at a rate of 65 meters per second. So it's a general understanding of relative velocity. You can also use relative velocity talking about x and y. You know, if you're talking that a plane is heading in this direction at 100 meters per second, and there's a crosswind of 5 meters per second, it turns out that the relative velocity of that plane with respect to the ground, because this is the plane's velocity from its point of view, is something like this, okay, which is about 102 meters per second, I think, about there. So relative velocity is just comparing your velocity, treating your velocity as stationary and watching all the other objects move around you. How fast are they moving away from you, or how fast are they moving at you, and in what direction? Okay, so that's a general understanding of relative velocity. Okay. Oh, I should make a note too that even though we had position that's relative to a point, and we have a velocity that is now relative to your velocity, there is no relative acceleration. Acceleration is acceleration. whether if this car is traveling at 35 meters per second and is accelerating at 5 meters per second, he would be 5 meters away for the first second, but the second he'd be 15 meters, the 5 and now another 10. So there's no relative acceleration. The car was still increasing its velocity by 5 meters per second. So there is no relative acceleration. We don't really consider that. There are cases in which we can, but we will not cover any of those situations. We won't talk about that at all over the entire course of this class. Okay? Relative velocity.